Here we go. Are you ready? Page T. Solving a trig equation means we're going to actually find the radian measure, like I like to say where. Okay, where that makes the equation true. Here's this. You can't divide by the cosine because you will lose one of your answers. So instead, we're going to subtract onto one side. So we have x cosine x minus 3 cosine x, and that's going to equal 0. So anytime we have an equation equal to 0, we can factor and use the ZPP, zero product property. So what's the common factor here and here? We have cosine, so we're going to factor the cosine out, and then we have x minus 3 equals 0. Okay, zero product property, ZPP, says if you have two things being multiplied equal to 0, then each one equals 0. So cosine of x equals 0, or x minus 3 equals 0. Let's do this easy one first. And if x minus 3 equals 0, then we're going to solve for x, and x equals 3. Now, cosine of x equals 0. We spent a lot of time evaluating the cosine. We would say, like, what's the cosine of pi over 4? What's the cosine of pi over 2? What's the cosine of 2 pi? Like that. Now we're going backwards. So we're saying, where on the unit circle is the cosine equal to 0? Okay, so what you need to think about is, where is the cosine equal to 0, and what is the cosine on the unit circle? It's the x value. Now, this should be a little confusing because we're looking for an x value, but then this is also x. This shouldn't be x, this should be theta. I don't really like that part of this worksheet. So where on the unit circle is the x value 0? You need to think of the 2 radians. So you go around the unit circle, and you either have it memorized or you're looking at a unit circle to find that answer. But the x value is 0. Where? Pi over 2 and 3 pi over 2. So those are our 3 answers. X equals 3, and then these 2 answers. Okay? Where does the cosine equal 0? That's what we just answered in radians. All right, this is a big old mess. It has all 3 trig functions, so the goal usually is to get it into one trig function. Do you see how this is sine squared and cosine squared? What do we know about sine squared plus cosine squared? It equals 1. So if we add this cosine squared over here, I'm not even going to rewrite sine squared plus cosine squared. I'm just going to say tangent of x plus, what does this turn into? A 1. It's kind of silly. So tangent of x plus 1 equals 2. Here we go. We're going to subtract 1. And now we're wondering, where on the unit circle is tangent equal to 1? So do you see how your unit circle needs to be very well memorized? So where is tan 1? Okay. So tangent's equal to 1, positive 1, at pi over 4 and 3 pi over 4. You are right, it is not 3 pi over 4. That would be negative 1. It is 5 pi over 4, and I should learn my lesson to not ever make a video without my whiteout by my side, but that's okay, yeah? Okay, how do we know that? Well, we did like 100 practice problems. You should have. Where we said the tangent of pi over 4 is 1, tangent of 5 pi over 4 is 1, tangent of 3 pi over 4 is negative 1, tangent of 7 pi over 4 is negative 1. So because we did it so many times going forward, now we should be able to go backwards. Okay? Here we go, 3 and 4 off of the paper of notes. This I'm thinking like, ooh, I want to try and factor it. I could factor if it was tan squared minus 1, but that 3 is really getting in the way. I can't factor the 3 out, so what we're going to do, what do you think we should do? We're just going to isolate the tangent. So we're going to add 1 And what else can we do? Then divide by 3. I'll show all my work. We're doing good on time on this video. Here we go. So 3 tan squared equals 1. Now I'm going to divide by 3. So tangent squared equals 1/3. We still need to isolate the tangent, and it's being squared right now. So what's the inverse of square? Square root. We're going to square root that. Okay, when we square root and we're solving, we need to have a plus or minus. Square root of that entire fraction, like that. All right, watch. Plus or minus. Okay, what is the square root of 1? 1. And then we have the square root of 3. We're going to rationalize this because we need to know where on the unit circle is tangent equal to this, and right now it's a little misleading. So never mind. Should we keep it like this? What's the definition of tangent? I think we should keep it like this. Okay, we're not going to rationalize. What's the definition of tangent? Y over x, or sine over cosine. So what we need to do is think about on the unit circle, where is the y value 1/2 and the x value square root 3 over 2. Do you see how that would give us 1 over root 3? So let me make my little mini unit circle here. 1, 2, 3, 1, 2, 3. And we want the y value to be the 1 and the x value to be the 3. So that's going to be this itty bitty graph right, or itty bitty angle right here, which is pi over 6. Okay, are there more answers? Yes, that's a positive. These were both positive, right? But it also could be negative, which means these could be different signs, right? So that's going to be back here at the reference angle. So do you know all your over 6's? 5 pi over 6. What about quadrant 3? Is that one of our answers too? Yeah, they would both be negative. A negative divided by negative is a positive. So we're actually going to have 4 answers this time. Are you getting where I'm going? Okay, so pi over 6, 5 pi over 6, 7 pi over 6, and then in quadrant 4, is that the 11 one? Is that cool? Fun, fun. Each of these a little bit different, but the knowledge of the unit circle is super important. All right, friends, here we go. We have cosine and sine. You can't really solve it if you have 2 different trig functions. So, do you see this sine squared? Okay, watch, watch, watch. You should have this memorized. Sine squared plus cosine squared equals 1. That's how I have it memorized. Isn't it cute? Okay, I don't write the whole thing out. I just write that. Sine squared can also equal 1 minus cosine squared. Okay, so that's what we're going to substitute here. Sine squared, we're going to substitute 1 minus cosine squared. Why? Because we can't substitute that cosine, but we can substitute that. So we're going to change this equation into terms of cosine only. From here, I'm going to distribute the 2. Now, is this a linear, a quadratic? You're like, what? It's a quadratic because of that square. So we're going to use the same techniques we used with quadratic x's and move everything to one side, and we're going to factor, okay? Factor and solve. You with me? Here we go. We can do this. You can do it. We're almost done. I'm going to add this 2 cosine x. Oops, it's a cosine squared. And then subtract this 2. So I'm moving all the terms to the left side, and the right side will equal 0. What we're going to do is we're going to pretend that this is 2x squared plus 3x minus 2. And how would we factor that? So what multiplies to get 2x squared will be a 2x and an x, yeah? But we're just going to write 2 cosine. So we have 2 cosine and cosine. And then what multiplies to get negative 2? 1 and 2, right? So we want this 2 to multiply by 2, because we want 2 times 2 to get 4. And then we're going to subtract the 1 cosine. So that's how we would factor this, 2x minus 1 times x plus 2. And we just did it, instead of x's, we used cosine x. Now that we have it factored, we're going to use a zero product property, and we're going to set each factor equal to 0. And solve for cosine. So here we're answering, where is the cosine equal to 1/2? And I still have my little chart over here. I'm getting a little tired, so it's not really in my head like it was before. I have an x value of 1/2 up here, so that's pi over 3. Now, where else is the cosine positive? Not in quadrant 2 and not in quadrant 3, but in quadrant 4. So what's the other angle in quadrant 4 that has a denominator of 3? 5 pi over 3. Good. Okay. Okay, think about your cosine graph and the range of the cosine graph, and how that cosine graph only goes from -1 to +1 and goes back down to -1 and up to +1 and down to -1. Yes? On that cosine graph, can cosine ever equal -2? No, it's out of the range. So for this piece of this equation, this piece has no solution. No solution, which happens sometimes, and that's okay. So those are our answers. Way to go, solving Trig.